Hello everyone, my name is Alvin and the topic of my research is a study on small-scale solar point concentrator for urban application. There are several photovoltaic systems out there in the world, but only two are focused upon in this study. In the flat plate conventional photovoltaic system, solar radiation is incident directly onto the PV panel, while in concentrator photovoltaic system, the solar radiation is focused onto a smaller receiver using an assembly of reflective mirror or lenses. Generally, CPV systems use multi-junction solar cells which offer higher efficiency to produce energy equivalent to conventional photovoltaic at a lower cost. The cost limitations can be achieved here by reducing the use of expensive semiconductor material, which can save up to 55% of the total installation cost of a conventional photovoltaic system. Moving on, let's talk about the research questions that are to be focused on in this project. First, how does the irradiation pattern of the off-axis reflector vary with the reflector geometry? For a given projected normal area, an off-axis reflector has a greater surface area compared to a conventional parabolic point concentrator. In addition, the relative location of the focal point of the off-axis reflector depends upon the equation of the paraboloid, which also determine the aperture width and rim angles. The next question is, how does the optical performance of the off-axis reflector compare with the parabolic point concentrator? Despite all the advantages mentioned earlier, CPV systems that are based on reflectors suffer from a loss called shading loss. This is due to the receiver assembly being mounted on a plane parallel to the reflector plane. In the irradiance map here, the shading loss is illustrated, which causes the system to lose up to 42 watts per meter square of irradiant power on the reflector. In order to conquer this problem, I propose the idea of using an off-axis reflector, which is a section profile of a parabolic point concentrator that allows the receiver to be offset from the reflector surface. While a standard parabolic reflector has the receiver assembly arising from the center, the off-axis reflector has the receiver on the side. Hence, any shading due to the receiver upon the reflector is avoided under normal incidence conditions. As shown on the irradiance map on the right, there is no shading loss for the CPV system with the proposed off-axis reflector. Shown on these three images here is the physical prototype that I had built throughout my final year project one semester. The image in the middle is the receiver mounted with multi-junction solar cells. And on the right is the slider system that allows the receiver to be adjusted with several offset positions. Why did the receiver have to be offset? During my initial trial on the prototype, the temperature goes up to 600 degrees Celsius on the receiver, which caused the multi-junction solar cell to break. The main reason for setting the receiver on an offset position is to increase the size of the focus image upon the receiver and consequently reduce the temperature on the receiver. Not only by setting the receiver to an offset position, an addition of a heat sink was considered as well. The heat sink was attached to the multi-junction solar cells, which allow the reflected heat to be distributed. Lastly, for future scope of my study, I would like to improve the prototype by optimizing the receiver placement in the prototype to attain maximum energy output and also would be able to minimize thermal losses. Another experimental trial to perform is to test the prototype under different weather conditions with the possible implementation of a solar tracker to increase the system autonomy. The global CPV industry is currently valued at $700 million and projected to grow up to $1.2 billion by 2026. This prototype can help fuel some of that growth by bringing down the cost of power production by CPV system up to 4.2%. The potential applications for the proposed systems they can either be installed on individual houses or they can also be installed with a greater number on commercial buildings. Thank you for listening.